Hello.
Good evening, sir.
Yeah, good evening to all. Shall we wait for 2 minutes? I think only two, three people are there, I think. Okay, we'll start. Today we are going to discuss on the one small practical example where we will calculate the loads and load path and loading diagrams. So generally, see, as we are using the software is taking care of all these things mainly, but for understanding the concept of load path and loading diagrams, we should also do this manually. So loads means all of you know that load is nothing but dead load, live load, earthquake load, wind loads, all these kind of loads. And load path means how the load is transferring from different members. So load transfer, we can say. Load path means load transfer. So general, what is the, if the gravity, if this is a building, let's say plan of the building, and if I ask you how the load will transfer, so what is the load path? So it will start from, let's say we have a building. All of you know that there is a building like this, any RCC building, high rise or mid rise. So there are beams, there are slabs in the building, slabs, beams, and columns, and footings also. Okay. So tell me how the load will transfer from where to where.
So from roof slab to beams and then from beams to columns.
So in general, slab to beam, beams to column, columns to footing finally. Okay. So this is general, we can say trend, and from every floor it will transfer. If it is a roof, let's say it is 4, 5, 3, 2, 1, whatever. So it from roof it will transfer here. Then again from this floor, fifth floor, it will transfer to the fourth. So generally this is the load transfer as far as gravity loads are concerned. Gravity loads, we can say. So slabs, all of you know that what kind of load slab is carrying. Slab is carrying dead load. That,
UDL.
yes, dead load. And dead load means self weight, we can say. SIDL means floor finish and other things. And it carries live load also, right? So it carries live load, dead load. Then what beam carries? Dead load, that is self weight of the beam, and wall loads. And what column carries the loads? Mainly dead load, that is self weight. Whenever I say dead load, it is a self weight. And other loads are coming from the beams. And footing finally, it is carrying self weight and all other loads coming from the column. So this is in general the load path as far as gravity loads are concerned. And okay, we are not going in detail regarding earthquake, but if I ask you how the earthquake load gets transferred, today we are only discussing gravity load, but if I ask you,
Laterally.
yeah, so laterally, so all of you know that there is a vibration in the ground due to earthquake. So these are the waves, or we can say oscillations, and there is a uh, left and right movement. And due to this movement, all of you know that when there is a movement, there is a velocity. And when there is a velocity, there is acceleration. Okay. So there will be acceleration in to and fro direction. And as there is acceleration here, this building will try to oscillate like this. Okay. And as the building tries to oscillate, the mass, there is a mass in the building at every floor, beams, beam weight, slab weight, everything. So each mass at each floor will oscillate to the right and left side like this. Okay. So this will oscillate like this. And as this mass is there and there is acceleration due to the moment, mass into acceleration, there will be horizontal force. So at every floor, there will be horizontal force generated due to the inertia forces. And inertia forces are due to the acceleration and mass of the building. So if it is a mass M roof, M5, M4 like this. So I'm not going in detail here today. It will come sometimes in future sessions. But this mass into acceleration, so there will be forces like this, FR, F5 means at every floor. And if you analyze this structure for the horizontal loading, then you will get bending moment, shear forces, axial forces. Now, what is the load path here in this case? So vertical load gravity is very easy. From top to bottom, it will go and come. So how it will go here? So horizontal to let's take smaller example of frame. So there is one case which is nothing but gravity case. Let's take one case, gravity, and second one is we have already discussed. So here there is a vertical load, gravity load, let's say. So the all of you know that from slab to beam it will go, and from beam to column it will go, and from column to footing it will go. So the load path is like this. This is your beam. This is your columns. So the shear, end shear of the beam, it will go down. So there will be a half load here going down and half load going down. And at the end, it will go to the footing. But if there is a horizontal load, let's say due to earthquake, how the load is transferring? Yes. कैसे transfer हो रहा है? Here we have a shear force like this. How it will transfer due to horizontal load? All of you know that. If you put this, there will be this load. There is a possibility of tension in this side and there is a possibility of compression in this side. All of you know this. There is a moment H into, let's say, height, this horizontal load PH, let's say, into height will be moment. PH into H will be moment. And to resist that, there has to be resisting moment. So this moment is causing clockwise moment like this. Globally, I'm talking, which is this M overturning, and there will be resisting moment, which will be anti-clockwise. M resisting, and which is nothing but this T into, let's say this L. Let's say this lever arm is L. So T into L will be the resisting moment. So you can understand even horizontal loads are transferred from beam to the column and like this. But in that case, it is not like this because this compression is downward only due to gravity load. But in earthquake load, there will be tension at some point, tension in some column and compression in other column. So this is the general load path. Finally, the load goes to the footing only, that is in the ground. So from footing, it transfers to the soil. So we have forgot that. So from footing, it will go to the soil or hard strata, we can say. So finally, the load goes into the ground because there is a gravitational, we can say, force. All of you know that. So all structure, all objects on the earth, they are static and they are resting on the ground in general. So this is the general load path for gravity load and earthquake load generally. Now we will take an example of one small, say, apartment building. And our aim is to draw the loading diagrams. And before drawing the loading diagrams, we will first calculate the loads. Now, where to start actually? So I'm assuming these beams and column locations are already defined. So we are working on the concept planning is already done. The column orientations, column locations. And I have also planned the beams over here because there is a wall architecture. This is also you'll learn in high-rise building sector, how to plan this and that. Currently, we are interested in just loads and load diagrams. Now you can see, I will tell you, once you start from the staircase, you will come in the passage and then you will enter here. Here there is an entry and here. So you will see there is, see, it's a 1 BHK flat. Okay. So here the entry will be there for 1 BHK flat and there here entry for this. So this is living room. This is kitchen and this is bedroom. Okay. And this is toilet. So please try to understand. And there are 4 flats similar to this: living, kitchen, bedroom, and toilets. So here is the entry for that flat. And there are walls all on all beams, because for having the partition of the rooms, you should have walls. So all walls are there. Wall thickness is, what thickness we take in wall thickness in general in practice? क्या रहता है wall thickness for buildings?
230 mm.
230 नहीं है, 150 लेते हैं nowadays, because okay, so wall thickness is 150 mm. Which material we use for wall?
Concrete.
So there are 3 types of material we use for as a brick. There is a brick wall, earthen brick we can say, earthen,
RCC wall.
or there may be concrete blocks like flash blocks, concrete blocks. So concrete may be one material, and there is third one is AAC blocks. So AAC block is a lightweight. Okay. So it is lightweight. Brick generally have a density 18 to 20 kilonewton per meter cube. Concrete block are having density roughly 24 kilonewton per meter cube, and AAC block are having 8 kilonewton per meter cube. It is very light actually. Nowadays the people are using this as the cost is also less and it is very lightweight. So overall weight of the structure reduces, and even earthquake forces also gets reduced, because all of you know that earthquake forces are nothing but mass into acceleration. So if you reduce the mass, then you can reduce the force, earthquake force. And even gravity loads are also less in the AAC block condition. See the density 8, and see here 20 and 24. So almost to 1/3 is this. But okay, for our training purpose today, we will take brick, earthen brick. So okay, this case I will take. But you should know the density, and whatever is the project's requirement, you can use whatever material you want. Now wall thickness is this, then there is a sunk. Let me check sunk. So what are the sunk available here in any structure? Sunks क्या लेते हैं हम? There is a sunk in the toilet. Why it is there?
Thickness of sunk, sir.
कितना लेना
125.
Sanitary fittings के लिए.
Yeah, for sanitary fitting we provide sunk, sanitary fitting and waterproofing, and it is generally say 200 and more, 200 to 300, let's say nowadays. Sunk for toilets. And if there are any terraces or balconies, so sunk for balcony, how much is that? Balcony or terrace?
125.
150 mm. Okay, standard practice is there. 150 mm for balconies and terraces, and 200 to 300 for toilets and bath. So this is the sunk. So see, we are trying to understand this first. And column sizes you can assume here 230 by 450 or 230 by 600. So it depends. We have last time discussed how to calculate the load on columns. And once you calculate the loads on columns, then you can design the columns approximately by using that formula. We have already discussed that. PUC is nothing but, sorry, PU is nothing but 0.4 FCK BD into, sorry, plus 0.67 FY AST. Okay. This is permissible stress in steel. This is in concrete. So this is your concrete capacity and this is your steel capacity. The total capacity is this much. So you can calculate the loads approximately, as I last time discussed, that using this like this. Okay. So we have already discussed the column loadings and all. Now we will discuss the beam and slab loads. Now first we start with the slab. So as we know, the load path is from slab to beam, beam to column, and column to footing. So we will start with the slabs first. Okay, so that will be, I think. So what are the loads on slabs?
So
First
dead
is,
load of slab.
yes, self weight, which is nothing but dead load, DL, let's say. Then second is floor finish. Floor finish, generally we put that into SIDL, superimposed dead load. Okay, it is also dead load, but superimposed we are also talking. Self weight means concrete members all. And what is the third load there in this on slabs?
Live load.
It will be live load. Okay. Now to calculate these loads, you know, to calculate any dead load, we require density and we require volume.
And volume.
So density into volume is weight. And for getting the live loads, you need to refer IS code IS 875 part 2. Okay. Now we will first calculate the slab loads and then we will shift to the beam loads and other loads. Okay. Now, as this is a living room and you can see the dimensions of the living room are 3 meter by, let's say, 4.29 meters. Okay. So now it becomes, so we have to assume the thickness of slab. So either you can design the slab first using Excel programs or manual calculation and then get the thickness, or I will give you guideline to decide the slab thickness for assuming the slab thickness. So if you want to assume slab thickness in residential buildings, if the span is near to 3 to 4 meters, then assume thickness as 130 mm or 125 mm is also fine. Okay. Or if you feel that there is you're not comfortable, then you can say 130 mm. If the span is 4 to 5 meters, then you can think of 140 mm. Okay. Assuming thickness. You can assume this thickness. And so let's assume thickness, slab thickness. Now you can see here our plan is having 3 meters and 4 meters span. So I can assume this as a 125 mm thickness. Here also. So even though they are smaller than that, you can assume the same. So this is also, let's say, 3 meters by 2.8 meters here. So let's assume all slabs to be, because they are all less than 4 meters. So you can comfortably assume as 130 or 125 mm also. Now for the calculation purpose, I am assuming 120 mm because some slabs are lesser. So see, I'm assuming somewhere more and somewhere less. So let's take average of 120 mm. So for 120 mm, what will be the weight of the slab? So now we will calculate the dead load of slab. So how to, now whenever we calculate any loads on slab, we calculate that in terms of kilonewton per square meter, uniformly distributed area. So कैसे निकालेंगे बताओ? So thickness 0.12 meters into density कितना है concrete का? Let's assume 25. So how much will it come? This is the thickness, right? So this is the self weight of slab. Then SIDL. Now SIDL generally I'm saying floor finish. So whenever you consider floor finish, do you know that in floor finish we have a screed? So if you have a slab like this, let's say ये अगर आपका slab है, ये beam है, ये slab है समझो. So you will provide one screed over here below the tiles, and above that there is a tile. So there is a tile. So this is your tile and this is your screed, concrete screed. So tile generally for calculation I can assume as 10 mm comfortably. 10 mm thickness tile and let's say 50 mm thickness screed of concrete screed we can say. Now, if I want to calculate the, so you know this thickness is 0.05 meters, means 50 mm. This one screed, and this tile is 10 mm is 0.01 meters. I want in meters because to calculate the load, I generally require meter dimension. So how to calculate the floor finish weight? Floor finish will be screed weight plus tile weight. So screed का weight कैसे निकालेंगे? We for any slab loads we calculate in kilonewton per square meter only. Okay. So बताओ कैसे निकालेंगे? So it is nothing but thickness into density of that material. So what is the thickness of screed? 50 mm. So 0.05 meters into screed. You can consider the density as concrete density, which is 24. And tile is, let's say thickness is 0.01 into tile weight. You can consider something. It is around 20 to 22. Okay. Something 22. So it depends. See, generally it is near to concrete material only because it is a cementitious material. It has a cement and all other material which are having density between 20 to 25. So you can consider 20.
Excuse me, sir.
Yes.
I have a doubt. We are calculating per meter square.
Yes. Yes.
Yes, sir.
For slab design and for transferring, we are calculating per square meter. So we are
Yes,
not
sir.
considering any length and width of the slab in this case. I'm just only considering thickness. So once I multiply that with thickness into density, 3 kilonewton per square meter. That means for every 1 meter square area, the load is 3 kilonewton. Okay.
Yes, sir. Got it.
Yeah. Now screed weight, then you can consider. So how much this will come? ये तो kilonewton per meter cube है. कितना आएगा ये बताओ?
So total 1.42.
0.22. Okay. So 1.42. So assume this as a 1.5 kilonewton per meter square comfortably. Okay. So floor finish, nothing but it is a SIDL. SIDL. So these terms we are using in modeling also. That's why I'm using this word also continuously. I know it is a floor finish. So the weight other than self weight of the member goes into the SIDL. Okay. So this is your floor finish. Now, so floor finish at we can say in rooms. Now there is one more floor finish here, which is nothing but ये निकलता हूँ मैं sunk. So we can assume some load for sunk. Sunk thickness I can assume 300 mm for sunk. So I'm interested in calculating SIDL in toilet area. Okay. So sunk is, let's say, 300 mm. So what will be the sunk load? So not sunk load, slab load in sunk area. So slab load, dead load, not dead load, SIDL. So kitna aega? So there will be load of sunk load will be there. So in toilet we have a sunk, so sunk load plus there will be screed below the tile, and plus there will be tile. So definitely there are tiles in the toilets also. So only apart from this there will be sunk. So I will just draw the sketch. So many times we can see the sunks like this. So this is a sunk slab. This one is sunk slab. So we are interested in calculating the load on this slab, which is sunk slab. And there is a sunk material over here, which, so this is a sunk material. Then we have a screed over that. Let's say this is a screed. And then we have a tile over that. So this is a tile. So tile thickness is 10 mm, which is nothing but 0.01 meters. Then screed, as I said you, 50 mm, which is 0.05 meters. And there is a sunk which we are considering 300 mm. So 0.3 meter is the sunk. So this is your sunk. Sunk is having material of brick. So you can consider density of brick here for sunk area. For screed, you will consider concrete density. And for tile, you will consider that 22 value. So what is the sunk slab load? So sunk slab load will be sunk load. So how much is the sunk load? 0.3 meters into density of brick, let's say 20, plus screed is 0.05 into 25 density of screed plus 0.01 tile into 22. So how much will it come? So last time जो आया था उसमें सिर्फ 6 ऐड करना है ना. So will it be
Total is 7.47 total.
so 7.5
Yes.
kilonewton per square meter is the sunk slab load. Okay. Slab load, which is SIDL only, not self-weight. Self-weight we have already calculated separately. Okay, please don't add self-weight of the slab here. Whenever you calculate SIDL, it is other than self-weight of the slab. So this is the load on this. Now let's go to the, what are the other loads are there on the slab? So we will first finish the dead weights. So dead weight slab ka hua, I think. Sunk and all floor finish. Now let's go to the wall load. So let's go to the beam loads. So beam loads में क्या क्या आएगा? First will be the self-weight of the beam. So whenever we calculate any beam load, we calculate in terms of kilonewton per meter. Let's assume size of the beam as 230 mm by कितना लेंगे? 500 mm. Let's see. So what will be the self-weight of beam here in this case? 0.23. So we want to calculate the self-weight for per meter weight. So what is the unit weight? 25. कितना है गई?
2.875.
So let's comfortable take 3 kilonewton per meter. Okay. Then wall load. Let's assume wall height as 3 meters. 3 meter wall height. Okay. And thickness, all of you know, 0.15 meters thickness. कितना आएगा wall load per meter? Please, beam loads are in per meter. Slab loads are per meter square. So कितना आएगा? So let's say thickness of, so this is your thickness. This is your depth. So similar to here, you can write thickness of the wall as 0.15 meters. Height of the or depth of the wall is 3 meters and density of wall is 20. How much is this? 9. Correct.
Yes, sir.
Now, whatever loads we are calculating now, they are all working loads. Keep in mind, all are working loads. At the end, we will multiply by 1.5 for making it ultimate loads. So this is your beam loads. And so we will only think till this beam and slab only, and that's it. Now, one important load is missing. That is nothing but live load. Okay, so which is required for slab loads. So slab load में live load कितना आएगा? So we will write down here itself. Plan में निकालते. तो living room को कितना रहेगा? How will you get this? Living room, kitchen, toilet, bed. What are the live loads?
IS 875 part 2.
So let's go into the IS codes and part 2 IS 875. And then you can so residential buildings, here you can see. So dwelling rooms, that is all rooms and kitchens, toilet and bathroom, 2 kilonewton per square meter. Okay. And if there is a corridor, passage, staircase, it is 3 kilonewton. So passages and staircase, it is 3 kilonewton. So that means it is very easy. 2 kilonewton is our case. So the load will be here. Living room is 2 kilonewton per square meter live load. Kitchen is also 2 kilonewton per square meter. Bedroom 2 kilonewton per square meter, and toilet also 2 kilonewton per square. Now this is your passage S5. What is the passage load, live load there?
3 kilonewton
It was
per
3
meter square.
3 kilonewton per meter square. And in staircase, same.
Same.
So similarly, you can write in all plan. So that whenever you calculate the loads, you will take it respectively. So once you draw these loading diagrams, once you draw the thickness, so what thickness I have assumed in the slab calculation load 120 liya tha na maine, just for load calculation. So I can assume this thickness of slab to be 120 mm, 120 mm. So all slabs I'm taking this. Okay. So which is required for dead load. Then I can write here sunk is 300 mm. So I can write down the inputs. I can write down wall thickness is 150 mm. So whenever you start with any kind of this plan, please write down the inputs. So these inputs are important, and height is, let's say, 3 meters. So generally we write down these inputs in the design basis report. You'll learn that in high-rise building sessions up in next month. How we prepare the design basis report. So everything what I am discussing with you, it is written in the design basis report. Now we have written the loads. So all dead loads and live load are mentioned on the drawing. And now our aim is to transfer the load. Okay. Now let's say my aim is to draw the loading diagram for B30 and B31. This is my aim. So how load is transferred, we have already discussed. From slab to beam, beam to column, it will transfer. Okay. So now tell me how the load will transfer from S4 to B4 and S4 to B31. Ye batao. So first we need to decide whether it is a one-way or two-way slab. That is our first aim. So is it one-way or two-way? S4 is one-way or two-way?
Two-way. Two-way.
And how to decide that?
LY by LX.
LY by LX.
Ratio.
So LY, अभी इसका S4 का LY by LX कितना आ रहा है? So S4, how much is the span? 3.2. So LY means longer span. This is 4.29. So 4.29 divided by shorter is 3.2. कितना आएगा ये? It will be less than 2. Therefore, it is two-way slab. So S4 is two-way. Even by observation, and so once you are familiar with this, you can even by looking at the plan and say that it is a two-way or one-way. So it is a two-way slab, and as it is a two-way slab, you know that it will have a triangular and trapezoidal load distribution.
Trapezoidal distribution.
Yes. So and on the shorter span, it will have a triangular, and on the longer span, it will have a trapezoidal. So shorter ये है ना मेरा 3.2 वाला, and then it will transfer like this. This will be your triangular, and then ये आपका trapezoidal रहेगा. Yes. So B31. So our aim is to draw the loading diagram for B30 and B31, and S3A भी यहाँ भी है. For the time being, as it is a two-way, let me assume as a one-way here, or what to do. Okay, ठीक है, two-way करेंगे. For the time being, shall I assume as one-way? Let's say ये one-way है, अभी करता हूँ मैं, just learning purpose. Let's say it is a one-way, it's not two-way. Let's say. So if it is a one-way, then what will happen? How much load will go to the B31? Half load.
Half.
So half load will go. So I can say this half load here will go B31 pe, and other half load will go to this B33 पे. So this is your load path, and it is same here because as it is a symmetric plan, it is same case. So this is the case we can see. Now, whenever the load transfer from slab to the beam, it will be converted into per meter load. So first it is a kilonewton per square meter, and once you multiply with some length, then it will be kilonewton per meter on the beams. So because on beams we have a kilonewton per meter loads. Now let's ये B30 and B31 पे load निकालना है हमें. So let's take this part separately. अभी एक काम करता हूँ. So how much is load? Now we have already calculated the loads. So how much is the slab load for S4? How much is the slab load? First is the dead load, then SIDL and live load. So we will consider both the loads. So dead load कितना आया था हमारा? Let's go back.
3 kilo.
It was 3, right? So see here you can see the slab dead load of slab is 3 kilonewton. So ये एक है case. Then we have got the SIDL, which is nothing but 1.5. So this is second load.
Yes, sir, 1.5.
1.5 is the SIDL, and then we have a live load which is 2 kilonewton per square meter. Okay. So dead load 3 kilonewton per meter square, SIDL 1.5 kilonewton, because for S4 there is no sunk, it is only tile and screed, and here it is like this, and live load is 2 kilonewton per square meter. So total load is
6.5
6.5
kilonewton
kilonewton.
7.6.
6.
6.5.
Sorry, sir. 6.
So 6.5 kilonewton per square meter will be the slab load, and I want to transfer this in two parts, that is triangle and trapezoidal, right?
Yes, sir.
And that will transfer here on this B4 and B31. So B31 we are having a trapezoidal load. Fine. Now there are formulas for triangular load and live load. Let's check it out. इसमें है. For triangular it is easy, but trapezoidal it is little different. So triangular load is WLX by 3, and LX is a smaller span. So how much is the W? हमने निकाला already. It is a working load W. So 6.5 into smaller span कितना है हमारा? LX.
3.2.
So it is 3.2. Here you can see this is the smaller span, and this is my right? This triangular load, which will transfer on B4. Okay. So 3.2 divided by 3. कितना आएगा ये लगभग?
6.93.
So 7
Almost
kilonewton.
7.
Yes, 7 kilonewton per meter. Please keep in mind, because now we have multiplied with the length. So because this load is kilonewton per meter square and this is in meters, so it will be 7 kilonewton per meter. And then there is one case, trapezoidal load, and there is a formula actually, WLX by 2 into 1 minus 1 upon 3 beta square. ऐसे है. Let's check it out. And where beta is nothing but Ly by Lx. Ly is bigger span and Lx is smaller span. So Ly कितना है हमारा? It is something 4.29. You can see here. This is my Ly, bigger span, and this is 3.2 is shorter span. So 4.29 and 3.2. So how much is this number?
1.3.
1.34.
1.34. Now if you put this in this equation, 6.5 into Lx is 3.2 divided by 2. 1 minus 1 upon 3, 1.34 square. कितना आएगा ये?
$5.7.
Let's say 6 kilonewton per meter. ये 5.7 ही आ रहा है क्या?
8.4 आ
So
रहा है.
there is a doubt, sir. The 3 is inside the square bracket or outside? In the formula 3 beta square, but in this 3 into 1.34 whole square. So
It's outside. Sorry. Okay, you consider that way. No. It is outside. ये
then
ऐसे
it is
3
right.
beta.
One.
कितना है गए?
8.5.
Now see how I got the doubt here. मुझे doubt क्यों आया? बताओ. आपने कितना? You said something 6 ना? Previously. So there is no problem in doing mistake or error, but you should find it out whether it is right or wrong. Actually, see, as triangular load should be less, isn't it? Trapezoidal load is more because it is having more span here. So trapezoidal load is in general is more than. So yes, 7 आ रहा है तो इससे ज्यादा ही चाहिए वो. Okay. So you can find out the mistake by some common sense in general. ठीक है. So it's 8.5, right?
Yes, sir.
So we have, these are triangular load on beams. So we have transferred the slab load to the beam. So I can say triangular load on beam. अभी ये किस पे जा रहा है बीम पे? कौन सा ये? B4 पे है. ये B4 यहाँ सभी जगह जाएगा. B11 पे भी जाएगा. Because ये ऐसा ही है ना. Fine. Now we have got this load and this trapezoidal load on beam also. So they all be. Now my aim is to draw loading diagram for beam B30 and B31. So loading diagram कैसे निकालेंगे? So B30, B31. So loading diagram, generally these are abstract images. You know that it is a 2-span beam. B30, B31. So this beam is my B30. This beam is my B31. and column numbers are this is C15, 15, 9 and 3. This is my C15. These are supports. These arrows mean supports. And we have a load on the B30 beam. I have load on B31 also. And what is that load that we are trying to? So we want to put the full load on this. So we will only write down the working loads here. अभी B30 पे कौन सा load है बताओ? Now B30 is having which load? ये हमने ये निकाला क्या वन वे का नहीं निकाला ना अभी तक S3 का लोड. So this triangular load is from S4. ये हमारा S4 है, S4 से ट्रांसफर हो रहा है. This is also transferring from S4. And there is one more load which we have missed actually, that is so we have calculated transfer this S4 load triangular and trapezoidal, but S3 is missing. So let's write down that S3. तो S3 में ये मेरा ये half load जाने वाला है. I'm assuming S3 as a one-way slab, as I already told you. Now what is this distance? 2.205. So half load means S3 का half load. So S3 load to beam will be W LX by 2, half load na. So W is 6.5, LX कितना है 2.2, 2.2, 2.205 divided by 2. So how much is this? 7 roughly
7.16.
7 kilonewton per meter, let's say, or let's say 7.2. Let's assume a little higher. Now tell me for B31 क्या रहेगा लोड हमारा? ये trapezoidal from slab, then self weight of beam and wall load. Yes or no?
Yes, sir.
So
Yes,
load on
sir.
B30. So let me summarize this load on B3. So B3 पे क्या क्या load है? So load on B3 is load on B3. So not B3, B31 is B31. 30B भी same है क्योंकि 30 and both are same, I think symmetric है ना ये. So B31 and B30. So कौन सा लोड है? From slab S4. S4 से कितना आ रहा है? S3 से कितना आ रहा है? Then self weight of beam and then wall load. इतना है ना loads? क्या क्या loads है? इतने ही है ना? From
Yeah.
S4,
Yes.
how much it is coming? Trapezoidal.
0.5.
So ये trapezoidal हमारा 8.5 था. So let's say it is 8.5 kilonewton per meter. S3 से 7.2. Let me assume 7.5. चलो राउंड इधर जरा समेशन आसान हो जाएगा मेरा. So it is 7.5 from S3. Self weight कितना निकाला था हमने? Self weight of beam ऊपर है ना, I think beam self weight 3 kilonewton per meter.
3 kilo.
So let's write down 3 kilonewton per meter. And wall load 9 kilonewton per
9
meter, right?
kilometer.
So the total load comes out to be 28. This is working load. Please, working. See, every time I write this working, because don't forget, sometimes people do mistake. They forget to multiply it by 1.5 whenever they design or calculate the bending moment diagrams. So ultimate case is important for design of any RCC members. But okay, we will, you can multiply here itself. Okay, let's multiply this. WU is nothing but 1.5 into. So मतलब ये ultimate load है now. I will write down here as ultimate. So कितना आएगा ये 1.5 से 42. That means now this load is nothing but by 42 kilonewton per meter. Again, this for 30 is also same, as it is a symmetric one. So this is my loading diagram. Once you get the loading diagram, you can calculate the shear forces, bending moments, and so on. And once you get the shear force, bending moment, you can design the beams. Got this? How to draw
Yes,
this
sir.
loading. Now, if you want to get the shear force, so if you want to get the loads on columns, all of you know that B31 will have a shear here. So V, you know that shear force diagram is generally like this. ऐसे कुछ तो रहता है. And this will also have like this. So there is a shear force here to the left of means from B31. ये shear रहेगा. Let me call this shear as a BV L31. मतलब B31 का left side का shear. This one. Okay. Then there is a shear force on the right side, which is V right 31 का. ये shear force यहाँ. This one. Then again here B30 का यहाँ shear है to the right side. So let's say V right 30. So this one. And then here V left 30. So on C9, which are the forces coming? So if I ask you to calculate the load on C9, क्या क्या आएगा load on C9? So load on C9 is ये वाला shear half. That means half load from B30, which is nothing but VR30 plus ये वाला shear force. And plus there will be self weight of the column. Yes or no? So load on column.
Yes, sir.
So it is shear from beams. So this is from B30. This shear. This is from B31. Shear.
Excuse me, sir.
Yes.
So I just want to ask that in this continuous beam system, if we are using the shear coefficients mentioned in the codes also,
Yes, yes, yes.
0.45, 0.40,
Yeah, you should do
0.60.
So whenever you calculate the shear force with VR30 or VL, you can take that 0.4 and 0.6.
Yes, 0.6.
Yeah. So you can take that if you do it manually, and if you are not doing, see, approximate calculation is half, which is very approximate. Little more or more appropriate would be IS code, as you said, 0.4 here and 0.6 over here. Multiply that values with
Yes.
W. And still more appropriate is software. Okay, because whenever I do this, I am assuming that my spans are same, my loads are same, and I am not considering the stiffness of columns in this picture. In general, no building is like this. Building is always have a columns which are having like this. Frame is there always like this. So there is a multi-story frame in buildings, and whenever there is a multi-story frame, there is a stiffness or moment of inertia to column. Let's say this is IC1, IC2. Then this beam, let's say beam 1, IB1, IB2. Let's say this is IC3. So all stiffnesses or moment of inertia of each beam is different. It may be different for all columns also. As there is a difference in moment of inertia, generally moment distribution is not so easy as we draw here, as we do it manually. That is whatever we learned in the manual concepts, it is not always the case. Real case is the, we can say, complex case, and which requires moment distribution method and stiffness matrix method. So due to that, even this 0.4 and 0.6 is also not valid. Okay.
Yes.
Finally, we are referring to the software results because they take care of all these moment of inertia also. So we know that distribution factor is something, it depends on the I upon L values in moment distribution. So there is a I important and L is also important. So this L, L1, then this L2. So if there is a change in L1 and L2, then also the coefficient changes and the moment distribution gets changed. So moment distribution is not as easy as such kind of simple problems. It is little complex and it requires software. That's it. Okay, but yes, to be more precise, this is good. to refer the IS code in such kind of problems, because you know that the span is same and loading is also same. So it is valid IS code method. Now this is your loading diagram, and how to calculate the load on C9 is this. In C15 का load कैसे निकालेंगे? C15 load on C15. So load on C15 is shear, this only shear of B30. So B30 का shear रहेगा इसमें, which is VL30 समझो, plus self weight of the column. Now we are forgetting one thing, that it is not only this load. Look at the plan. So this C15 is carrying this B18 load also, don't forget, and B19. So you need to draw the loading diagram in this direction also. Yes or no? ये direction का भी load चाहिए ना? Then and then C15 will, you can calculate the loads of C15. So I'm just here also B11 and B12 is there. So in this case, how we do that, I will tell you. So So we have drawn the loading diagram of B30 and 31. Now, if I ask you to draw the loading diagram of B11 and so okay, B11 and B12. So you know that B11 पे कौन सा load है? ये वाला load है, right? ये वाला, sorry. Triangular load of this. Then what load will come? If it is a one way, will there be any load from slab S3? यहाँ load रहेगा कुछ B12 पे?
Yes, sir.
See, one way है ना, तो ये load तो पूरा इधर ही जा रहा है. So there is no load from S3 for on B12. Okay, so no load on this. Then there is a load from here. S2 से load रहेगा यहाँ half. As it is a one way, so half load will be here. And again, as there is a slab over here, so from this S4 also there will be load, triangular load. And again, as it is a one way slab here like this, so there will not be load in this zone from S3, as it is one way. Okay, and here it will be there, same. So what loads will be there? So from S4 triangular load here, then from within this zone there is no load. And please understand there is a secondary beam there, B32 and B33. So there will be point load from B32 and B33. Correct? So if I ask you to draw the loading diagram of, let's forget this for the time being. अभी इतना ही निकलता हूँ, B11 and B12. Okay. So B11 and B12 will be So you can see from a triangular load of S4 will be here on B11. This is your B11 beam and this is your B12. Okay. So B11 पे कौन कौन सा लोड आने वाला है? So the triangular load from both the slabs, correct? And you know
Yes,
how to
sir.
calculate that. तो ये B11 पे क्या रहेगा? Triangular load S4 का रहेगा, दोनों S4 का, दो from here and here. प्लस और क्या रहेगा इस पे बीम 11 पे?
Wall load.
वॉल लोड प्लस और क्या रहेगा? सेल्फ हिट.
Wait.
So you can calculate as per the similar procedure. Now here is within this zone you can understand that there is a point load from B32 and B33. So I will just write down the downward load like this. So this load is nothing but summation of B32 shear and B33 shear, correct? Half from here and half from there. And is there any now here यहाँ क्या load रहेगा this zone में? थोड़ा कलर यूज कर दो. What is this load? B12 पे कौन कौन से लोड रहेंगे बताओ? Is there any slab load?
Self weight. Dead load.
So it will be wall and self weight. That's it. No slab load because it is one way. I'm assuming this one way इसलिए. Okay. And what load will be here now in this area? यहाँ क्या रहेगा load? S2 का, right?
Yes, sir.
So load from S2 plus. So whenever I say load from S2 means self weight of slab, SIDL, sunk load, वो सब floor finish सब कुछ जो हमने निकाला है already इसके लिए. Okay. You know that how to calculate the sunk loads. Sunk load निकाला क्या हमने? नहीं ना? We have calculated that ना कुछ तो ऊपर
Yes, sir.
निकाला है. So you can use that value of sunk loads. So there will be
25.
yes. So S2 से रहेगा, then it will be wall load and then it will be self weight of beam. Now you know how to calculate these triangular loads, wall load, self weight, but there is a question how to calculate the B32 and B33 load. अभी ये कहाँ से लेना है? Shear from, because I need to put the point load here in this. So I know and these columns are nothing but ये मेरा कौन सा है? C9 है ये. This is my C9, this is my C8, this is my C10. Okay, we'll discuss that. अभी यहाँ क्या रहेगा लोड बताओ? B10 पे. If I consider B10 also, तो ये मेरा B10 है. And there is a continuation में बाकी तो symmetric है, so I forget it. So यहाँ भी एक लोड है. कौन सा लोड रहेगा ये बताओ? So here from S5 plus from staircase load ST. Then again self weight, wall and self weight. Correct? समझ में आया सभी को? How to draw the loading diagram. So this is it
Yes.
will give you a feeling of load path. कहाँ से कैसे लोड जा रहा है and how to calculate the loads. So that is the main aim of this today's session. Understanding loads and load path and drawing the load diagram, because all of you know that once you draw the load diagram, then you can calculate the bending moments and shear forces. I know this is not an easy task because the load is different at every part and we need to use the softwares in this case, or you can use moment distribution method, but it's a really tedious job. As a matter of we can say study, you can take this example simple, and all of you know that we have calculated this is an indeterminate structure. So how to calculate the bending moment of indeterminate structures that we have already discussed. Either you can use that method or you can use IS code method for calculation of this. If you want to calculate this, then it is really we can say challenge for you. You should have a lot of patience to solve such kind of problems manually. So it is really a challenge, I would say. So this is your load path now. Yes, B32. So if you want to calculate the shear from B32 and B33, then you should solve the B32 and B33 first. तो पहले आपको B33 और ये दोनों को solve करना पड़ेगा. So how can you solve? तो यू नो दिस की B30 ऐसे सेम रहेगा वैसे ही। कौन सा है B32। सो अभी मैं देखो कैसे निकाल रहा हूँ, ये यहाँ एक सपोर्ट है और यहाँ एक सपोर्ट। अभी B32 का क्या हो रहा है, ये लेफ्ट साइड में किसका सपोर्ट है, B19। सो दिस एरो इज नथिंग बट B19। Not necessary always there will be columns, because my this B32 we are resting on B19 to the left side, and to the right side it is resting on B12. So ये मेरा B12 है। So these beams are resting on the beams, and यहाँ B5 है। So these are my supports. Now again you will see that there is a load coming, point load coming from the B14। तो यहाँ कहाँ तो है वो, ये this is my B14 point load here, and here my B7 point load। नाउ अभी लोड बताओ कहाँ कहाँ से लोड आएंगे। सो B32 में, दिस इज माय B32, देयर विल बी लोड फ्रॉम विच स्लैब, S1। S1 में कौन सा लोड रहेगा, मे बी ट्रेपेजॉइडल रहेगा, करेक्ट। S3 वन वे है मेरा, तो इट विल बी वन वे लोड। विल देयर बी एनी लोड फ्रॉम S1? S1 पे इस पे लोड आएगा क्या कुछ, नहीं। सो B32 विल हैव अ लोड फ्रॉम S3 जो मेरा वन वे है, देन इट विल हैव अ लोड फ्रॉम S1 विच इज ट्रेपेजॉइडल लोड, एंड देन वॉल प्लस सेल्फ। यू कैन इग्नोर इन दिस जोन क्या रहेगा, इन दिस जोन टेल मी।
Wall load and self load.
दिस वन, ये जोन है मेरा, अभी बोल रहा हूँ मैं। तो ये मेरा क्या रहेगा, S3 का लोड है इस पे, है ना, यहाँ से आ रहा है। तो S3 लोड इज देयर, S3। S1 का है क्या लोड यहाँ, इस जोन में नहीं। S1 S2 का है क्या, नहीं है। सो वॉल एंड सेल्फ, गेटिंग। Any doubt here in this zone?
So the S2 is not coming on this beam.
No, because this S2 is transferring load to B12 and B14, yes or no? Because this is one way,
Okay, yes sir, yes.
ये one way है ना।
Yes sir, got it.
Yeah, so इस पे लोड नहीं जाएगा। But yes, it is going indirectly. So S2 will transfer the load on a B14, and then B14 का point load यहाँ जाने वाला है। So I understand that this will load go, but not directly here, but indirectly from B14 to here. Now again there is a problem that I am having a problem with B14, क्योंकि B14 का point load कैसे निकालेंगे? So B14 का point load के लिए again draw the loading diagram of B14. So whenever you start drawing any loading diagram, start with the first secondary beams. So this is my secondary beam number one. Then secondary beam is transferring load on the one beam, we can say secondary beam. So I would say this is primary one, B12 is primary one. So yeah, B14 is transferring to B32, B32 is transferring to the B12. समझ में आ रहा है? So what loading diagram should I draw first? B14. And even though you forget it, don't worry, कहाँ तो समझ में आएगा ऐसे, अरे हाँ यहाँ भी B14 चाहिए। So now let's draw the loading diagram of B14. So B14 कहाँ support हो रहा है? So B14 is supporting on B32 on the left side and 34 on the right side. So B32. And what are the loads on B14? So what कौन से load है? Then there this one is B14 पे triangular load है, S1 triangular and S2 का one way. So there is a load S1 का triangular load, S2 का one way. Then you have wall load and self weight. All loads will be there. And once you get the loads, then you can calculate the shear force here. V left and V right. And this shear force is nothing but it is transferring to the B32. So whatever this shear force you get, VL32, let's say, VL14. So VL14 you will transfer here. So यहाँ number आएगा. समझो यहाँ 50 kilonewton आया number आपका, समझो shear force का. Then it will be 50 kilonewton, let's say. So this is the load path. So you should draw all the loading diagrams like this. So you have this plan in front of you. For other beams, you can also say यहाँ कर सकते हैं आप. As a matter of study, you can draw loading diagrams for different beams. You got this? Generally, how to draw the loading diagrams.
Yes, sir.
And this is very important. You please write down the loading diagrams for different plans if you have any plans with you, or we will share with you for matter of study. And draw loading diagram. इससे क्या होगा? आपका load path will be very clear, because in structural engineering the important part is the load path. Loads and load path rather. Calculation of loads is easy, but load path may be different. अभी यहाँ मुझे बताओ, as a question I'm asking you, on B26, if I draw loading diagram of B26 and let's say B27, तो B26 पे कौन कौन सा लोड आएगा? So it is a tricky. If plan फिर से कॉपी करो क्या? B26 पे कौन कौन से लोड से?
So trapezoidal load from S4 slab.
So yes, so there will be trapezoidal from load from S4. So S4 trapezoidal. Okay, and then
Wall load.
wall load plus
Self weight.
self.
Staircase.
So now tell me, will there
Half of stair.
no? Here there is a trick. There will not be any staircase load on this B26. Now think over it and tell me. See, direction of staircase, you see this. See, all of you know that staircase is inclined. And this beam is at floor level and this staircase is inclined, which is only transferring load on B17 and B10 only. And the direction is this one. This is your staircase direction. And all of you know that if it is a one-way slab, then it will not transfer the load to the lateral direction. Yes or no? Only this. So B17 and B10, there is no load from staircase on B26. Keep in mind. And even B28. इस पे और इस पे जो load नहीं जाने वाला. Getting? समझ में आया load path?
Yes, sir.
So there cannot be load transfer from staircase to B26. 10 पे रहेगा, 17 पे रहेगा. And that's why I asked you this tricky question. So please keep in mind how the members are supported. Then and then you can understand the load path. First of all, the slab has to be connected to the beam. Then and then slab can transfer the load to the beams. That is first case. So it is not Ly by Lx. First case is there has to be beams which are connected to the slab. अभी ये slab इसको connected है क्या? B26 को नहीं है ना? It is at different level and staircase is inclined. So slab has to be connected with beams. First criteria, then check this ratio. And then decide is it one way or two way. So this is the, we can say B26 load. quickly I want to लेकिन मेरे पास है क्या plan अभी, just me check this. Now in this case, you'll see there is a balcony portion over here. So previously we were not having any balcony in this. So all of you know that there is alternate balconies available, alternate terraces in multi-story buildings. So for one room there is a balcony at lower floor. For other room it will be different balconies. So alternate balconies are there. So you can see here there is a balcony here. As it is a balcony, you know that what kind of beam is this? ये वाला beam कौन सा है ये? There is no support of this beam, na?
Cantilever.
So it is a cantilever because this NB1 load is transferred to the cantilever as a point load and then it will go back, right? So if I ask you to draw the loading diagram of this CB1 and say B24, समझो मुझे ऐसे निकालना है तो tell me कैसे दिखे? CB1, this is my CB1 and this back beam is B24. Then this left side, this column is C12. And behind that, it is a C6. C6 है ये. बाकी वो continuation में है. You can see this. Okay. Now B24 पे तो load कहाँ से आएगा वो you are very much now comfortable with this. So this will have B24 will have load from S3. If you assume one way, it is a half load. If you assume trapezoidal, it will be trapezoidal. Whatever you assume. So S3 plus S4 से trapezoidal रहेगा and then wall plus self. It's very easy. Now here tell me what load will come on this CB1. CB1 पे कौन कौन सा load रहेगा? Tell me.
So self weight,
So CB1 में yes self weight रहेगा.
parapet wall,
Parapet wall, yes, because in balcony we have parapet, not full wall. So let's say parapet wall plus self weight and any other load.
wa-
ये S6 का spanning कैसे मेरा? One way है ना?
yes sir,
So this will not transfer any load on this CB1, right?
yes sir,
So no
It
need
will
to
be transfer on NBI and NBI will
NB1,
transfer point
वो
load
transfer.
on CB.
Yes. So to complete this, so there will be parapet wall and self weight on beam directly, and please understand there is a point load here from NB1. So I will also draw this NB1 point load. NB1. So यहाँ आप NB1 की value लिखेंगे, shear की value NB1. And for that you need to draw the loading diagram of NB1 first. So NB1 will be तो NB1 पे लोड क्या रहेगा? NB1 है मेरा, तो द लोड ऑन NB1 विल बी फ्रॉम S6, राइट? S6 का वन वे लोड, हाफ लोड, S6 से हाफ लोड रहेगा, S6 वन वे, मतलब वो WLX/2 बोलते हैं, LX/2 प्लस NB1 पे वो पैरापेट एंड सेल्फेट, पैरापेट प्लस सेल्फ, राइट? कुछ तो प्रॉब्लम, सेव हुआ कि नहीं पता नहीं अभी। ये so okay, we were discussing NB1. Yeah, let me again write it. So this will be NB1 shear here, then this will be parapet plus self, okay, and NB1 is one way load from S6 plus parapet plus self. Then you will get the shear force. All of you know that the NB1 is resting on this CB1. So this is my support CB1. Again, this is my support CB1. So whatever shear force will come here from this loading diagram, you will transfer that shear force here as NB1 here. So shear from NB1. Here you can put that number. So this is your loading diagram for cantilever beams. I hope you got all this in general.
Yes, sir.
Yeah. So here you can see this SIDL is written here, LL is written 2, then SIDL is 8, that is sunk load and everything. So generally, whenever we do any major projects, we need to first prepare the loading plans. So this is nothing but a loading plan where you need to mention all loads, live loads and SIDL on the plan. And then you can use this, you can add these loading plans in the design basis report where you are putting the calculation inputs and everything. And then you should use these design basis and loading plans for ETAP modeling. So there is a standard way of working that we will study ahead. First of all, try to understand the loading plans for gravity loadings. So ये बहुत important है. So any questions?
Excuse me, sir.
Yes.
Sir, in this example, this cantilever slab,
Mhm.
if we cannot provide any beams in that
Mhm.
slab
Yeah.
from the architectural point of view,
Mhm.
then how the load will be?
Yeah. So समझो ये बीम नहीं है हमारे पास, no issue. Let me ignore that. I don't have this beam. I don't have this beam also. I am having a cantilever slab like this. Generally cantilever ऐसे दिखाते हैं. Okay. So this slab is cantilever slab. So all of you know that. And this is a B15 beam behind. So I need to calculate the load of S6 first. Okay. तो S6 पे कौन कौन सा लोड आएगा? So S6 is having load of sunk, tile and screed and live load. Okay. समझो ये sunk is having load, let's say 8. So sunk plus floor finish plus live load. So sunk का समझो 8 है, floor finish समझो 1.5 है, screed plus tile, and live load is, let's say in balconies we have live load as 3. All of you know passages and balcony. So let's say it is roughly 13 kilonewton per meter square. It is a slab load. So this is your live load, this is your floor finish, and this is your sunk. So 13 kilonewton per square meter will be the load, and as there is no beam over here, as we have already, this is only a slab, no beam there around anything. So this full load, this is a cantilever slab, and it will transfer directly load to the B15 full load. That means what will be the load on B15? If I draw the loading diagram of B15, समझो मुझे निकालना है, then it will be full load मतलब कितना span है मेरा 1.845. So the load on B15 will be, ये समझो B15 है, 1.845 into 13 full load, जो कुछ आएगा समझो 25 something kilonewton per meter. So this will be the transfer of load from S6 to B15. Yes, getting? And
Yes, sir.
if you want to design the S6 slab, so this was the load transfer on the beam. And if you want to design the S6 slab, then you need to calculate the bending moment. So what will be the loading diagram for S6? So S6 का loading diagram कैसे है? So there is a fixed, यहाँ fix है ना मेरा. This is my S6. The span is 1.845, and this is my S6. And what is the load on that? कितना आएगा load? Oh, sorry, 13 ना? S6 का load. Yes, this is slab loading diagram. Slab loading diagram. Okay. So how much is this? 13 kilonewton per meter square. Yes or no? यही है ना load. So this is my slab
Yes, sir.
loading diagram. And then I can calculate the bending moment. M is equal to WL square by 2. So ये 13 है. M working बोलता हूँ मैं. L is let's say 1.845 कुछ आएगा. Square by 2. So whatever number comes here, let's say 25 kilonewton meter. Let's say. What will be the ultimate moment? 1.5 into. So you can take these moments and design the slab. But yes, there is a procedure of design of slab, assuming thickness and D effective and so on. That you'll learn that in next month. But yes, you can calculate the bending moment of cantilever like this, and you can design this slab S6 for this moment. Okay. How to design that we will learn. So this is the process if it is the case. And one more point, that in this case you need to assume little more live load actually. क्या होता है बहुत बार यहाँ है ना, even though we provide say cantilever slab without any beams, there will be some railing or glass railing or whatever. So there will be some point load here at the end. So as a matter of, we can say, additional safety, because people put some load, so you can take some point load here also of parapet wall. Generally don't allow parapet walls if there is no beam. You can tell them you can have a glass parapet or lightweight parapet like railings, but don't go with the brickwork without beams, because it will deflect the slab and there is an issue with the shear and all this. So better way don't. So please convince the architect to keep these beams maximum possible. Okay. And if he's not agreeing, then tell him don't put any brick parapet wall over here. He can think of glass or maybe lightweight railings. And whenever you are considering glass or lightweight railing, then add point load also here. So ये वाला glass railing load समझो. So you can calculate the railing load by assuming some thickness and steel का weight वगैरह निकाल के. And then you can add in this moment. ये point load समझो इस यहाँ है समझो, let's say 1 kilonewton is the load of the railing. Then 1 kilonewton into 1.845. 1 into 1. So it will be additional moment. Roughly it will be say 27 total. And then you need to design for 27 S6 design. So this can be the choice of designing such kind of slabs. Okay. Any other
So,
questions?
excuse me, sir.
Yes, yes.
So, if it is we are calculating on the plan. If it is a multi-story, then we have to add the loads coming on the beams and
No,
slab
no,
of
no,
the
no, no.
upper
Beam
floors
slab
also.
can. No, no, no. That addition is only for the columns, not for the beams. Beam is there itself. So every plan you will draw that, but you will not add anything. Huh? You can see the addition is here at the support level. Support level पे add हो रहा है
Okay,
ना सब.
okay, sir.
यहाँ से फिर
It
आगे
will
जा
go.
रहे हैं ना.
The load will transfer through column. Okay, okay.
Columns, हाँ. अभी समझो ये B25 है. So you are drawing this B25 at this level only. Once there is a shear at the end, it will transfer to C2. Then CB1 का shear यहाँ जाएगा. Then B1, B. So it will transfer to the column and column will transfer to the down floors. Okay. So we are not
Yes, sir.
doing any summation of the beams and slabs. They are at that level only. And that's how we independently draw the loading diagrams of every floor. And we sum these reactions. ये वाले जो reactions है ना ये वाले. And then जहाँ जहाँ C12 दिख रहा है तो I know that, let's say if I see this C2, let's say. So C2 I will find where I will find the C2 in this loading diagram. तो मेरा loading diagram एक है ना ये वाला. So there will be B1 and B2 loading diagram. So here I will find one C2 here. यहाँ ऐसे है ना C2. ये reactions. Then I will find here also CB2 and CB25. यहाँ एक reaction दिखेगा. C2. So in the two loading diagrams, I will find C2, then add those C2 together, and then I will get final loading on the C2. Got it?
Yes, yes, sir. So,
Yeah.
but the columns above this column that we are talking C2, if
Mhm.
any other column is above it, then it will also transfer the load to C2
Mhm.
or it is
No, it
separated.
depends on the load, means how you are arranging. See, generally the columns are above the columns. Only what you are talking that the column may be different if there are floating columns or such kind of arrangement. Then and then the load transfer may be little different. But in general, see, we know that the column is there above these 6. It will be till the roof level generally. Only in floating cases, it may be different. We can discuss that separately. How the floating load transfers. The same, we have to calculate the column loads and transfer. Let's say यहाँ एक floating column है समझो. Do you know floating columns?
So it will extend in the roof supporting.
No, say floating columns means, say, let's say, I'll draw a section. चलो, questions आए तो. Why I say floating? The reason is, समझो, let's say this is your building and there are footings over here, let's say below this. Now all these columns are going above. Let's say C1, C2, C3, and C4. Okay, so generally it is the case in any building. We have the columns. They from bottom, that is footing level, to the roof level they go. It's very easy framing system. Sometimes architects are say interested. Sometimes what they do, let's say they want some hall over here. Let's say, okay. So there may be some requirement of the architect that I want big hall over here, and please don't put this column here because there will be problem for my functional requirement. Let's say there is a banquet hall. So banquet hall generally have a bigger span of the rooms, and there will not be any columns in between. So he may say that, please remove this. So what we do in this case, I will remove this. So C2 is removed. But yes, I have taken that C2 from here to above. Let me call it as a FC2 because it is a floating now. So my FC2 is floating from this beam. So this beam, I call it as a transfer beam, TB. So now this beam will have more load here. So how FC2 is transferring the load यहाँ से यहाँ तक जाएगा ऐसे. Then it will transfer from here, here, here. Let's say you calculated the load of the column from here. Let's say it is 100 kilonewton from transferring this on FC2. Then again here 100 kilonewton. Column load, again 100 kilonewton, column load, again 100 kilonewton. So how much is the load which is coming on TB transfer beam? 500 kilonewton. So if I draw the loading diagram of TB1 or that transfer beam, so it should look like this. So ये मेरा TB है, ये मेरा कौन सा तो beam है समझो, let's say B1. Okay, so I will have a load of slab and other loads at this level. ये level के slab load भी रहेंगे. And I will have a point load of FC2, which is accumulated, cumulative load, which is nothing but 500 kilonewton in our case. So this will be huge point load on this beam. And then this transfer beam will transfer this beam load to this C1 and this C3. So definitely this kind of cases, the bending moments are huge like this. So there may be bending moment like this, and the numbers are so huge that the size of the transfer beam requirement is very high. So this is also one kind of, we can say, as you ask me, if there is some issue with the column location above. See, this is the generally floating column cases. Getting a load path?
Yes, sir.
Okay, so I think today we will close a little early, I think. So I hope all of you are practicing on this.
Yes, sir.
Yeah, yeah. So thank you all.
Thank you, sir.
Thank you, sir.
Thank you and good
Thank
night to
you,
all.
sir.
Good night, sir.
Good
Good night,
night.
sir.